Oh, good. I'm so glad you came back for the example. Okay, so here's the example. Okay, so you assume that they intersect. Okay, otherwise I wouldn't be giving this an example. Okay, but a slightly longer question might be, prove that two lines intersect. Okay, and find the angle between them. I'm just going to go straight to this. Okay, so your vector A is this, vector B is that. Okay, and they intersect and find the angle between them. Okay, using the scalar product to do that. Okay. Now, if you want, you write it out like this. You don't have to. Okay, so 8, -5, -4, and then dot, where the dot represents the scalar dot product, 5, 4, -1. Okay, right, what do we do to work it out? Okay, now we're going to do that times that, for 8 times 5, okay, which is 40. Let's write it here, shall we? 40. -5 times 4, which is -20. -4 times -1, which is +4. Okay, so just add those together. 40, 20, 24. Okay, so the scalar product is just that, the number 24. So the answer is just not really useful to us in what we're trying to do. Okay, what we also need to do is do the other definition of the scalar product, which is the modulus of that times the modulus of that times cos theta. Okay, so we're going to have 24 is equal to, and then the square root of 8 squared plus 5 squared plus 4 squared times the square root of 5 squared plus 4 squared plus 1 squared cos theta. Okay, and let's just simplify this a little bit. So we're going to have 64, 70, 80, 105, root 105, and then here it's going to be 25, 31, 41, 42 cos theta. Just make cos theta the subject. That's going to be 24 over root 105, root 42, work out value theta. That's it. Okay. Hope you're starting to smile because this is like really easy, isn't it? Okay, so root 105 multiplied by root 42. Okay, it's 20 on root 10. So let's take the reciprocal of that, and let's times it by 24. Okay, 0.3614, just checking you got the same thing. Then inverse cosine of that, make sure you calculate in degrees mode. Okay, 68.8 degrees. 3 significant figures. There, that's it. Simple. Okay, every single scalar product question is exactly the same. Okay, you've got your vectors. Okay, you just put the numbers in. There, simple. Okay, I'll do another example in the next video. Okay, so here's the next question. Maybe pause the video, have a go. Just take just a few minutes. Alright, let's do this then. I'm going to do this one a little bit quicker this time. Okay, so we're going to do that times that, that times that, that times that. So it's going to give me -7. I still write this down. I don't like doing too much in my head. Okay, because mistakes happen, of course. So -7, subtract 2, and then plus 6. Okay, so work out that is, so -9 plus 6, -3. Okay, that's the scalar product. So if you ask what the scalar product is, that is it. Okay, so -3, then is equal to, and then 9 plus 1 plus 1, root 11. And then 49 plus 4 plus 4, that's 50, the hell's the matter with me, 57. Okay. Oh, look at that, prime numbers. Kind of interesting. That's not a prime number, no, scrub that, okay. Cos theta is equal to -3 over root 11, root 57. There we go. Let's work out thetas, okay. Cos theta is negative, okay, so do you know what that means? Okay, here's the cos graph, okay, so 90 degrees, okay. If the cosine is positive, you answer between 0 and 90. If the cosine is negative, you answer between 90 and 180. We'll discuss that point in a minute, okay. So let's just do that, so -3 divided by root 11 divided by root 57 equals -0.1198. Inverse cosine of that. 96, there you are. I told you. 96.9 degrees. 3 significant figures. What's the significance of that, you might ask? Okay. First of all, did you find it easy? Really hope so, 'cause it's easy. It's really easy, okay? It's not difficult. No idea why they took it out of this year's Year 13 syllabus, but it's really, really easy, okay? What's the significance of that, okay? So here you've got two lines intersecting. In the first example I showed you, the last video, okay, we had an acute angle, okay? That's obviously an acute angle, okay? Now we've got an obtuse angle. Your question should be, how do you know whether it's acute or obtuse? Just by looking at the diagram, okay? Well, what happens is, you've got a point of intersection there. If you get an acute angle, then the vectors are either both pointing away from the point of intersection, or they're pointing towards the point of intersection like that, okay? So in my previous example, if I was to do a sketch, it would look like that, okay? Now, when it's an obtuse angle, okay, like this angle there, that's an obtuse angle, what happens is, instead of having one away and the other away, you've got one away and one towards, okay? Or one towards, one away, okay? I'm not going to prove that for you, but it's a generalisation, okay? So when it's an obtuse angle, it's because one vector... So in this example here, this would be a slightly inaccurate diagram, you see? So if vector A was that and vector B was that, it would be more appropriate to draw it as something like this, or arrows the other way, okay? But anyway, I hope you found the example useful. Right, still with scalar product. What do you think is the significance of this if A dot B equals 0? Give you time to think about it. If you still not got the answer, I hope you pause the video. If you still not got the answer, let me just write down again what one of the definitions of scalar product is. Mod A, mod B, cos theta. So what we're saying is, if A dot B equals 0, we're saying that this equals 0. Now, assuming that they're not 0 vectors, that can happen, let's assume they're not. Assume that A is not 0 and B is not 0, in other words, they're not 0 vectors, then mod A is just a scalar, mod B is just a scalar, in other words, numbers. You can just divide both sides by those numbers, and you end up with cos theta equals 0. And what is the value of theta when that's 0? 90 degrees. So what's the significance? It means the lines are perpendicular, or the vectors are perpendicular, okay? So when you got A dot B is equal to 0, that implies that they're perpendicular, okay? That fact makes it very, very easy to come up with two, if you want, random vectors that are perpendicular to each other. Let me show you, okay? So I'm just going to write down some random numbers, 2, 5 and 9, okay? I want to come up with a vector that's not a 0 vector, it's not 0, 0, 0, such that they're going to be perpendicular to each other. Can you do that? Okay, right, what I'm going to do is this, okay, I'm going to just make that an even number to make it simple, okay, so that's going to be 18, okay, I'm going to make that -2, so that I'm going to get -10, and I'm going to make that -4, so that becomes -8. See how that works? Okay, so that's going to be -8, -10, plus 18, okay. Can you find a different one? Let me show you a different one, because I've just noticed straight away those are all multiples of 2. So I'm just going to divide all of those by 2 to get 2, 1, 1, and I'll check it. -4, -5, 9. Okay, gives me 0. Okay, so it's quite simple to do. Okay, it's also handy if you want to prove or show that two lines are perpendicular. Okay. So you know other methods of showing that you've got perpendicular lines, okay? There's the gradient method, the product of the gradients is -1, okay? Now you've got the vector method, okay, which is also pretty handy as well.